calculus. I got a great question from one of your classmates just on clarifying how to do the graph of sine and cosine if you know the amplitude and period. Because while it's a good idea to plug in a few points to check and see if you're correct, really if you know the amplitude and the period, that is a shortcut to getting to the graph. My number one suggestion is, if you're graphing a variation of sine, it's helpful to just pencil in what normal, plain vanilla, 1 amplitude, 2 pi period sine looks like. Or if you're graphing a variation of cosine, just pencil in what does normal, plain vanilla, 1 amplitude, 2 pi period cosine look like. Because then that gives you sort of like the guideposts of how to alter it according to what is in the formula. So I'm doing ones that you guys are already familiar with, that we've done in class and have been part of our conversation, so that you can see a different way of how to get to the graph from the equation without calculating all the coordinates. So here on the board we've got y equals sine x, and our modified equation is y equals 2 sine x. So the first thing to notice is that our b is 1, meaning we're not changing the period at all, meaning the places where the graph crosses the x-axis, the nodes, the equilibrium spots, those are not going to change. So everywhere that sine is 0, 2 sine of x is going to be 0. So this is why I say, having regular old sine penciled in, if you know the period hasn't changed, then you know that all the zeros are going to be the same. So that makes that really quick. Now, we know that the amplitude is 2 instead of 1. So that means that everywhere that sine is 1, now it's going to be 2. And everywhere that sine is negative 1, now it's going to be negative 2. So So we can put these points in here, and then all we have to do is connect the dots. And voila! Now we have the graph of 2 sine x. Now, it may be that as you do more and more of these, you start to remember that unaltered sine has all of the zeros at whole pi's. So you'll notice sine of x has its zeros at 0, pi, 2 pi, 3 pi, 4 pi, and so on and so forth. So if you want to write yourself a little note that's kind of like a shortcut, if you're doing a graph of sine and the period has not changed, the zeros are at the whole pi's. Again, if you're doing a graph of cosine and the period doesn't change, your zeros are at all the half pi's. Half a pi, 1.5 pi, 2.5 pi, 3.5 pi, and so on and so forth. And so that can be a quick way to start putting in the guideposts if the period hasn't changed. And then all you have to adjust is how high the amplitude is based on what your A is. Alright, but let's say that we instead were changing the period. So here our amplitude is not changed, it's still 1. Sometimes I will pencil in a dotted line here just to remind myself that it's kind of like, okay, that's where the amplitude is going to be. The amplitude is 1, the amplitude has not changed. However, the period has changed, and so in this case, it's cosine 2x, now I know that I'm going to have to fit 2 complete cycles into what is normally 1. Or as a reminder, to find the period, it's 2 pi divided by b. Here this is 2 pi divided by 2, and so that's going to equal pi. So now I know I've got to complete my cycle in just pi. Now this, with the period, this is where the symmetry of trigonometric function graphs is really important. If my 2 peaks are at 0 pi and 1 pi, my trough is going to have to be halfway between them. So that's going to have to be at half a pi. And my nodes are going to be halfway between my peaks and my troughs. So this graph is going to have to cross the x-axis here at a 1/4 pi and a 3/4 pi. So I'm starting from the period, which is pi, so I'm knowing where my cycle is going to have to end. And then I'm just using symmetry. The trough has to be halfway between the peaks. The nodes have to be halfway between the peaks and the troughs. And so these sort of guideposts, they're always going to be, equidistant from one another. And then once I've got the pattern, so here, now I can connect these dots, now I can just repeat it. I'm going to have to complete the next wave in 2 pi, so I know I've got to get to here. My trough is going to be halfway in between. So my trough is going to be here. My nodes are going to have to be halfway in between the peaks and the troughs. So my nodes are going to be here and here. And so on. So, to summarize, if the period doesn't change, if b equals 1, then the zeros will not change. So you can just put down your zeros of sine or your zeros for cosine, and then all you have to do is adjust the amplitude. Is it going up to just a half? Is it going all the way up to 10? And so on and so forth. All right? Here, if the period changes, then a reminder that 1 troughs fall halfway between peaks. Peaks fall halfway between troughs. Oops, my spelling. And nodes fall between a peak and a trough. So when the period is changing, then you're using the symmetry of the graph, the fact that troughs fall halfway between peaks, peaks fall halfway between troughs, and nodes fall halfway between a peak and a trough. If you know the period, you know that when you need to get back to where you started, and then you can back up to those halfway points in order to find the rest of the markings. Now, let's say that you have an equation, like for example, let's say that you had y equals 2 sine of 2x, and so you're modifying both the amplitude and the period. Because changing the period is more difficult, there's just more steps involved. My suggestion is that first you pencil in, okay, what does sine of 2x look like? Just kind of pencil that in. So first you can pencil in sine. Then you can pencil in sine of 2x. And then finally the last step will just be to stretch the amplitude up to 2. Then my suggestion is that you pick some intermediate values to plug into your calculator to see if it matches what you have on the paper. Okay? The final piece of advice that I have is, what if you have y equals, for example, negative 2 sine of x? What does that negative do? The negative flips the graph over the x-axis, and so here we still have the same starting point, but instead of going up to 2, we start out by going down to negative 2, and then up. So that negative just kind of like it means instead of starting out going up with sine, we start out going down. Likewise, if we have, for example, y equals negative cosine of x, instead of starting at 1, we're starting at negative 1, and then doing the pattern of the cycle for there. So hopefully those are some helpful guidelines on how to graph sine and cosine functions based on the equation with the information about the amplitude and the period. But of course, if you have any additional questions, let me know. Good luck.